All right, so we start with the very first one. For those of you that are joining us at home and can't see it, these are minus signs. All right, no problem. Now, this is going to be x plus 2, x minus 3 if we factor it, over 3x plus 4, x plus 3, x minus 3. What's the common denominator? X plus 2, x minus 3. You got to write down everything you see. X plus 2, x minus 3. What else do we need? X plus 3. Now, do we need the x minus 3? No, it's already there. The x minus 3 is already there, so we can just go ahead and check that one. So your common denominator is x plus 2, x minus 3, x plus 3. Now, over here, I've got the x plus 2 and the x minus 3. Which one am I missing? I'm missing the x plus 3, right? So if I put the x plus 3 on the bottom, I must also put it plus 4 over x plus 3, x minus 3. What are we missing? X plus 2. If I put the x plus 2 on bottom, I must also put it on top. Okay. Now, extend the line. Right? Extend the line. A lot of people start canceling off. Don't do that. Okay? You got to resist that urge. All right? And it's very common that people want to do it, and I understand why you want to, because you're used to being able to do it in the other sections, but it doesn't. You got to multiply and add first. So we're going to have 3x squared plus 9x plus 4x plus 8 all over x plus 2, x minus 3, x plus 3. Now, I'm telling everybody to extend the line. If you choose not to extend the line, then when you get it wrong, don't blame me. Okay, you need to extend the line because the minus sign, it can mess you up if you don't. Okay. 3x squared plus 9x and 4x is 13x plus 8 over x plus 2, x minus 3, x plus 3. Now the question is, does this factor? I don't know. 4x, 6x, 10x. Nope, we're good. Now you'll notice that I didn't try anything else. I just needed to know if there's an x plus 2. If there was an x plus 2, then those would cancel. That was the only thing I was really concerned about. As long as there's not an x plus 2, I don't care whether it factors or not. You see, if that factors, say, for example, say it factored to 3x plus 5, x plus 7. Well, I don't care about that. Why? Because none of these pieces are down here, so it's not going to cancel if it does factor. The only thing I have to worry about is whether it cancels and ultimately, or factors and ultimately cancels. Since it doesn't, then we can just quit. That is our final answer. Circle that puppy and move on. Okay. Any questions on the first one? X plus 4, x minus 4. What's your common denominator? Common denominator is x plus 4, x minus 4. Now, here I've got the x plus 4. What am I missing? I got the x plus 4. I'm missing the x minus 4. If you put it on bottom, you must also put it on top. I've got the x minus 4. What am I missing? I'm missing the x plus 4. If I put it on bottom, I must also put it on top. Now, extend the line. Don't just distribute without extending it. 2x times x is 2x squared minus 8x. Minus 5x times x is minus 5x squared minus 20x. Here you go. That minus sign right there, the number one mistake people make. Look down at your papers. Do you have a minus 20x or a plus 20x? If you got a plus 20x, it's probably because you didn't extend the line. I said probably. I didn't say for sure. Okay? That minus sign in the middle of these two problems causes more problem for people in terms of messing up the equation. And the worst part is, if you don't get that minus sign distributed, oh boy, your answer is going to be wrong, and there ain't, the only way to get it fixed is to get lucky. All over x plus 4, x minus 4. So now we got negative 3x squared minus 28x. Is that right? Over x plus 4, x minus 4. That minus gets you, you would have gotten 12x and you would have felt real good about yourself.
I actually did.
And then you would have canceled?
Yep.
Yeah.
If you, x plus 5 factor at the top.
It doesn't factor. I mean, it does,
Yeah,
but it doesn't factor where you can cancel, so I don't care.
did I do it? It's fine?
Yep.
Okay.
Did, and that's fine too. All right. A couple observations about this one. X plus 5 squared over 4x times 8x cubed minus 12x squared over x squared minus 25. One of the things here that I see, and if you did this, it's okay, and I'm not a big fan, whenever I believe in trying to be positive in terms of, like, don't tell people what they shouldn't do, tell people what they should do. Just as a rule of life, go with that. But I want to say this. I see people who take x plus 5 squared and go x plus 5, x minus 5. That's not right. X plus 5 squared is what? X plus 5, x plus 5 again. Okay? And anytime you see it written like that, write it out side by side. It'll help you in just more ways than you can ever count. Okay? You gotta trust me on that. X plus 5 over x plus 5. This is 4x. This is times. Now, x squared minus 25 factors to x plus 5, x minus 5. Right? Now, 8x cubed minus 12x squared.
I took out 4x
We're taking out 4x squared. And it's going to be 2x minus 3, yes? Now we want to start canceling. X plus 5 cancel. Wanda, can you see that okay? I know sometimes I use green and I probably should use something more bold like red. Except red's kind of a negative color and people get kind of taken back by it. What? Oh my God.
I thought that you were supposed to find a common denominator for everything, so I screwed it the whole time.
That's only for addition, subtraction, solving, and complex fractions. The question was, when do we find a common denominator? Now, the 4 and the 4 cancel. The x and one of these x's will cancel. That'll just leave one left over. Does anything else cancel? So you're going to have x plus 5, 2x minus 3, over x minus 5. And that's your final answer. Yes, sir.
Oh crap, I got the right answer. Yeah, we're still the same.
I wouldn't find a common denominator, though. All right. The 4, let me answer the question. The question was, what happened to this 4x squared and this 4x down here? The 4 and the 4 cancel because it's multiplication and division. Across the diagonal. There's 2 x's up here, right? X times x. One of them is down here. So one of them here and one of them here will cancel. It just leaves a single x, which is what you see here. I apologize, Brent. Let me pull it down some.
Was that just a fluke of how I got it right?
No, I mean, you could find a common denominator. It doesn't change anything, but you don't have to. It just makes it more difficult. It's a lot more reducing when you get done, I would think.
Yeah, it was. It was like a 17-step problem.
Yeah. Yeah.
Why should say that?
I would say to you that when this class is over, I'm going to go. I have to go to Washington D.C. today, so I'm leaving to go on a nice little road trip. You could.
Back Monday? Or we get
Yeah, I'll be back Monday. Yeah, Lord willing, I'll be back Monday. My point is, I could start the trip and head to Miami first if I needed to. If you find a common denominator, you detoured yourself to Miami first. Not to say you can't get there, just say you can take you a few more steps, a couple more hours. Okay. Now, this is where we left off, and I say we, meaning we being you and the sub, left off and did yesterday. Okay? Now, I'm trusting that Juana has a great idea.
I think it's the last answer.
Let me pause. We'll let Juana look. What's the common denominator between these four? AB squared. Do we agree? So we're going to multiply each piece by AB squared. AB squared here, AB squared here, AB squared here, AB squared here. Now, when I say the common denominator, it's got to be the common denominator between all four of these. Somebody last semester gave a dryer. I thought the common denominator down here was just AB. Why is it AB squared? It's not the common denominator just for this one portion of it. It's for all of these. Okay, very important that you hear that. Now, when we do this, basically we have four problems we have to work. We have to deal with 16 over A times AB squared we have to deal with a over b squared times ab squared. So let's just deal with those two for right now. 16 over a times ab squared, what do you get? You get 16 b squared. Because the a cancels. I'll explain this in a second because this is confusing. B squared cancel. And you have a squared. Okay. Now, on the bottom piece, we're going to have 1 over b times ab squared, and we're going to have 4 over a times ab squared. So what do I have here? The b and one of these b's cancel, right? So you're left with ab on the bottom. Then here, what do you have? Minus 4b squared. Okay. Yeah, I'll explain it to you in 1 second. Okay. All right. Now, can we factor this? Can we factor? 4b plus a, 4b minus a, over, what's common? B is common, you're left with a minus 4b, yes? Right? The b is common to both, so I take it out, and I'll be left with a minus 4b. So let me write that somewhere. So we factored the top, 4b plus a, 4b minus a. We factored the bottom, we took a b out. You're left with a minus 4b. Do we agree? Now what you notice is that this and this will cancel, but it cancels not to 1, but it will cancel to negative 1. The same way that when you have 8 over negative 8, you can cancel these, but you don't get 1, you get negative 1, is the same way these will cancel. 4b minus a minus 4b, they're basically the same thing. They're off by a sign. So you can cancel them, but you got to keep the negative sign. And so your answer is 4b plus a over negative b. Say it again, please. Great question. 8 plus 5 over 5 minus 8 is not the same thing as 8 minus 5 over 5 minus 8. You see here, the sign is the same for both. They're still both subtraction. So the rule for subtraction is going to be the same, right? There you're adding one and you're subtracting the other. That's not the same thing at all. Does that make sense? So I think you're seeing it as, well, the letters and the numbers are the same. The sign is the major difference. Right, negative 4b plus a. Okay. By the way, this is your final answer. All right, I want to pause that. Let me pause. All right.
Oh, so this one's easier.
It is.
Yeah.
Why is it easier?
Because it's
So yes, this one might be considered a little bit easier because it's x plus y, x minus y. So your common denominator is x plus y, x minus y. So you got to do x plus y here, x minus y, x plus y here, x minus y, x plus y here, x minus y, and x plus y here, and x minus y. Now again, what's the objective of doing this? Clear the fractions. Not make them the same. Get rid of them all together. X minus y cancel. You're left with 2. X plus y. The x plus y cancel. You're left with 5. X minus y. The x minus y and the x minus y cancel. You're left with 5. X plus y. Minus here, the x plus y is cancel. You're left with 2. X minus y. Now, bless you, Katie, I do see a lot of people who at this moment get really excited. And they just want to cancel everything. They're looking at it like, this is God's will right here. Ain't no way this happened by itself. This was on purpose.
But you don't, right?
No, you cannot. Even worse than that, yeah, no, you cannot do it because you can't just cancel pieces. That's like trying to cancel 16 and 64, right? You can't just cancel pieces just because they look the same. All right? Even if it works once in a while, you can't do that. Multiply it out. And then if you can simplify, you'll be able to simplify still. Okay? 2x plus 2y plus 5x minus 5y over 5x plus 5y minus 2x plus 2y. Do we agree? Now combine like terms and let's finish this up. 2x plus 5x is 7x. 2y minus 5y is negative 3y. 5x minus 2x is 3x. 5y plus 2y is 7y. And that's all you can do for that.
So you don't have to.
I agree.
So you don't have to take it and flip it and multiply it or anything.
Yeah,